How does this function for the fine structure constant? Well, let's take a system with one unit, right? And then let's square it. 1 times 1 is just 1, right? Now, let's add two systems. Right now, we're just going to use the number 1 so that we can compare the system and not the numbers in the system. Well, what is a system of two ones? That's 11. So 11 times 11 equals 1, 2, 1. Let's look like a pattern here. 1, 11 times 11, 1, 2, 1. So let's go a 3-digit system. 1, 2, 3 times 1, 2, 3. And again, I'm going to use my calculator. Actually, I don't need to for this because it's, you understand the system. It's 1, 2, 3, 2, 1. You're starting to see a pattern here. So let's go to a 4-digit system. 4 ones times 4 ones is 1, 2, 3, 4, 3, 2, 1. 5. 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5 is 1, 2, 3, 4, 5, 4, 3, 2, 1. Getting the pattern here? 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6 equals 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. Okay? Let's keep going. 1, 2, 3, 4, 5, 6, 7 times 1, 2, 3, 4, 5, 6, 7 is 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1. Let's do it with 8, and we're going to do this through 9. We can go through 12 right now. 7, 4, 5, 6, 7, 8 times 1, 2, 3, 4, 5, 6, 7, 8 is 1, 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 2, 1. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 1, 2, 3, 4, 5, 6, 7, 8, 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? And for this model, for this theory, we're going to stop there because there's no need to go any farther. So what does this tell us? Well, when you take a single-digit system and multiply it by itself, square it, it's still just itself. When you take a 2-digit system, and again, we're not focusing on the numbers right now, so every number is 1 to make it easy to see the patterns. So 11 times 11 is 1, 2, 1. Well, what is the highest prime factor, right, of this number? And the answer is 11, and it's 11 squared. Okay? Well, what's the largest prime factor of 1, 2, 3, 2, 1? The answer is 37 squared. And this is going to be 101 squared, right? And 5 is going to be, I don't remember 5. Better do this real quick so I don't get it wrong. 1, 2, 3, 4, 5, 4, 3, 2, 1. Divided by, I'll just Google it real quick here. Largest prime factor of 1, 2, 3, 4, 5, 4, 3, 2, 1. And this is 271 squared, right? And 6 is 37 squared again. And 7 is, that's a good question. I don't remember some of these off. I can't remember 7 right off the top of my head. But 8 is, of course, 1, 3, 7 squared. And this is the fine structure constant. 9 is 3, 3, 3, 6, 6, 7 squared is the largest prime factor. And I'm going to try and find this one real quick. Largest, that's not good. Helps if I spell it right. (4649) squared, that's why I can't remember it. It's a unique number. It's the first real prime. I'm not going to get into that right now, but now, what does all of this prove? Well, it proves that 137 is a lot like 37 and 37 and 333667, right? So I've said that 1 is neither, 3 is 1/3, 6 is 2/3, and 9 is 3/3. So what does that mean? Well, 136 plus 1 is the fine structure constant. And it stands for 1/3, no thirds, 1/3, 2/3, plus 1. And that means that 333666 plus 1 is the macrostructure constant, and 3, 6 plus 1, both here and here, are the microstructure constant. So 3, 6 plus 1 is the microstructure constant, 136 plus 1 is the fine structure constant, and 333666 plus 1 is the macrostructure constant. And why would I be saying that? Right? Well, because everything is linear and orbital fields that are neither one, the other, or both. One, the other, neither, and both. And this is how they come out in the structure of geometry in number theory as you extrapolate them. Why is that important? Well, it's important because let's have a little fun. Right? 37 times 37 equals, right? So the fine structure constant multiplied by 37 squared, which is the largest prime factor of this number, comes to 1, 3, 6, and 9. It's not a joke. 37 times 37 on 6 then would be 1, 3, 6, and 9. And the fine structure constant, 137 times 137, and this is where it is. It's 9 and 18 around 76, or 18, 7, 69. This isn't, right? It's hard to understand, which is why a lot of you got lost. But now let's take 333,667 times 333,667. Oh, well, this calculator doesn't show it, but it comes to 111,333,666,999. So 1, 3, 6, and 9 orbital fields on 3, 6, and 9, all 333,666 plus 1. 136 plus 1, 36 plus 1. What is the fine structure constant? I guarantee no one's ever told you that it's neither one, the other, plus 1 squared. Why is this important? What am I just making this up? Is this just another place that it pops up? Well, let's look at it. Honestly, mathematically. If this is an 8-digit system, and by the way, if I'm right, and I am, and Mercury isn't a planet, it's a moon, then you have the star, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. We have 8 different positive and negatively charged primary particles in our system. Why is that important? How does it manifest itself in the other things we see so that this isn't just a coincidence? Well, let's take our 8-digit system right here, 137 squared, right? Which I'm telling you is 136 plus 1. And what we're going to do here is we're going to define in an 8-digit system, right? 1, 2, 3, 4, 5, 6, 7, 8. How can we possibly break this down evenly, symmetrically? Well, you can have 8 all ones. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8 divided by the fine structure constant, 137, equals 81103. Let's try that 8-digit system. And again, I said we're going to use ones just to make it simple, but now let's go 2. 1, 2, 3, 4, 5, 6, 7, 8 divided by 137 equals 162, 206. Thing is if you look at this and you put spaces, 22, 16, 6. So now you see the algorithm, what I call the algorithm of polarity. Any 8-digit system, no matter what number you put in, if they're all the same, is divisible by 137 evenly, and it creates a polarity structure of 8, a magnitude of 11 by 3. Okay? And to me, this tells me the structure of our solar system. And here's why. You want to know how electromagnetism comes about. Well, you can take 8, 2, 3, 4, 5, 6, 7, 8, and you can break it in half, right? 4 here and 4 here. So let's try that numerically. And by the way, any 8-digit number with all the same digits is divisible by 137, period. So let's try it with two numbers of 4. Let's go any random 5915. Whoops. 5915. 5915 divided by 137. Look at that. It's a whole number. And it gives you another structure. Right? So let's try any other. 3573 divided by 137. Whoops. That didn't do. No. 3573 divided by 137 equals 260,829. Why is that important? Because it lands on a whole number every time. So if you symmetrically break down any 8-digit system by the fine structure, it's divisible by the constant, the fine structure constant. And this is true of any of these. Okay, so like 3 can only be divided evenly in thirds. You can't break it down any farther. 6 can be broken down as 2 digits of 3 or 3 digits of 2. Okay, but 3 is already covered. So let's go 2. Right, 6 digits. So let's say 23, 23, 23 divided by 37 equals an even number. It will always, in any symmetrical system, it's always divisible by the constant. And this tells you what else. So 1, 2, 3, 4, 5, 6, 7, 8. Let's divide them into 2s. See if we can't break this system. Right? Let's try it. So let's try 7, 8, 7, 8, 7, 8, 7, 8. The digit 7, 8 repeated 4 times. Divide that by 137 equals, again, evenly divisible, and the numbers come out in a way that tell you something about the structure of the system. So any 8-digit system, like our solar system, divisible by all the same, so all 1s, all 2s, all 3s, all 4s, whatever digit, is divisible by 137. Any 4-digit number, whatever you choose, repeated twice, is divisible by 137. Try it. Any 2-digit number, repeated 4 times, creating an 8-digit system, is also divisible by 137. So this tells us that 8 can be divided 8 once, or 4 twice, or 2 4 times evenly. So this is an 8-digit system, right? And these are the forces. You may not understand it, but this is the equal and opposite 4x2 and 2x4 of electromagnetism. How do I know that? How is that, and how does this lay out? Well, 9. Let's go to the next one. 333,666 plus 1, or 333,667, is the macro structure constant I'm saying. Well, 9 can be divided, right? Any 9-digit number. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's try it. I don't know if I can on this calculator, but let's try it. 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 333,667. Look at that. Why? Because the macro structure constant divides 9 evenly no matter what. Let's try it again. You can't do it 2 and 4 because it's 9, so it's the only other option is 2, 3, 4, 5, 6, 7, 8, 9. You divide by those 3 and those 3 and those 3. So let's try it again. Let's go 7, 8, 7, 8. Whoops. 7, 8, 7, 7, 8, 7, 7, 8, 7. Just divided by 333,667 equals 2361. You see how that works? Now, this is divisible by 33,366 plus 1, right? And so is this. So if this is if this is charge and this is force, or electromagnetism, divided in our 8-digit system by the fine structure constant 136 plus 1, or what you call it 137, then the same thing is true of any of these numbers and their constant. And that 1, 3, 6, and 9 all share and 1/3, no third, or 1/3, 2/3, no thirds, and 3/3. And this is what these are, and this is how the systems can be broken down to create the forces. So let's just say that that's right. What would these 3 separated into thirds be? Well, this is a tetrahedron, this is a tetrahedron, this is a tetrahedron, and together these make the eigenstates of mass, which is a way of saying that our solar system is an 8-unit system, which is why we find everything divisible by 137, and that our galaxy is a 9-unit system, which is why it's divisible by this number evenly, 333,666 plus 1. And that all of the forces we see or understand, like electromagnetism, as defined by 4x2 and 2x4 in an 8-unit system, is the same as the eigenstates of mass, 333, out of a 9-digit system, divisible by the macro structure constant. So we have 36 plus 1, the microstructure constant of 3 and 6, and we have 137, or 136 plus 1, the fine structure constant in our 8-unit system, which is our solar system. And then we have 9, which is our galaxy, divisible by 333,666. And when you multiply 333,667 by 333,667, or 333,666 plus 1, it is 111,333,666,999. And I couldn't make this stuff up. So why do I know that these are the eigenstates of mass and that they represent our galaxy? Well, this is the electromagnetism and represents our solar system. Well, let's have a little fun here. What was I going to show you? The eigenstates of mass here, and these here. Let's create the digital root of these. If you add 1, 3, and 7 together, you get, or in this case 136 plus 1, you get 9, 10 plus 1 is 11, right? And 11 times 11 is 121. And this is the speed of sound. Sounds funny, right? Why would the speed of sound be 121 in this numerical system? But let's watch something. Let's take 333, okay, and add it to 666, which creates 999 plus 1. And remember, these are all squared. Largest prime factor of all of these are squared. So let's square 999 plus 1, or 1,000. 1,000 squared is 1,000,000. So the speed of light, right, 1,000,000 times almost faster than the speed of sound. Well, if you take the largest prime factor of an 8-digit system, it's 11. 11 times 11 is 121. That represents the speed of sound. If you take 333, 666 plus 1, you get 1,000. 1,000 squared is 1,000,000, and that's the speed of light represented in the solar or the galaxy. We actually get to see the eigenstates of mass compared to electric and magnetic fields, which are divisible in our 8-unit system by the fine structure constant, and all of these things still apply. You can see the forces mathematically built out in number theory, because number theory is just built on a measurement of 1 multiplied by itself, geometrically building out in an orbital field of 1, 3, 6, and 9.